Here is an explanation for the answer to final exam question number 71 in Physics Demystified, 2nd edition. If you have the printed version of the book, please see page 530. The question asks us, in an alternating current electrical circuit, the resistance, the capacitive reactance, and the inductive reactance combine as vectors to give us a complex number what? Well, in an alternating current circuit, we have resistance that starts at 0 and can increase positively. We do not define negative resistances. The reactance is an imaginary number quantity. Capacitive reactance is negative imaginary, which I've indicated by writing minus J. Remember, J equals the positive square root of minus 1, the J operator. That's what makes it imaginary. And inductive reactance is positive imaginary. So we might have a point here indicating a certain number of ohms of resistance, a certain number of positive imaginary ohms of reactance. That would be inductive reactance, and we can draw a vector from the origin out to that point, calling the resistance R and the imaginary reactance Jx, where x is a positive real number in this case. Contrary-wise, we might have a certain amount of resistance, a certain amount of capacitive reactance. Then we get a vector like that, which we can write as R plus Jx, where x is a negative real number, or R minus Jx, where x is a positive real number. The reactance is sometimes spoken of in ordinary real number terms in overly simplistic electronics courses. But here are two vectors. We can also, of course, have vectors that go either straight up or straight down, representing, say, pure inductive reactance, pure resistance, or pure capacitive reactance. But we never see any vectors going off that way because, again, there's never any such thing as negative resistance in the impedance plane like this. So the answer to this question is E. The vectors that we have drawn here, all of these, are complex number impedance vectors.